Hey guys, welcome to the blog. So we're finally going to start building this closed deck EJ257 engine. So plan today is it's out of storage. It's been to the machine shop, and since it's been in storage I've lubricated all the sort of bearing surfaces, machine surfaces, down the bores, things like that. So I'm going to clean the lube off and also just give everything sort of a water wash first to make sure there's no small machinery filings and cuttings left in the blocks. After that I'll probably wash it down again and then dry it off with some compressed air, and then we'll be ready to check the clearances, tolerances, things like that. So today's a bit of a cleaning day, and also in my toolbox I've been separating out the parts. We've got the Mal Performance pistons and Manly rods. So these are actually the turbo tough ones. They're good for like 1,000 horsepower or something, which we'll never reach, but sure, why not. I've also got some bearings, ACL race bearings, and a whole engine seal kit in there. What else have we got? We've also got the 14mm head studs, and the block and heads have actually been machined for that. So that's another machinery job that you have to get done at the same time as a bore and a hone and the closed deck conversion, because what they do is they actually drill out the head, the holes for the head studs, because originally they're about 10 or 11mm studs you use, so you go up to 14, you need the channels bored out, and also that closed deck surface put in, and the water jackets and everything. So there's a lot of machine work that goes into actually preparing the bare block if you want to go to this level. The engine that's currently in the car, it's a semi-closed deck, and it was just bored and honed, and some Manly sport pistons in it and rods, so it's good for, it's about 440 at the wheels at the moment, and it's amazing how quickly you get used to that. So this build, I don't know, there's no real upper or lower limit. I just want a nice, I don't know, I'll be happy with 600 really, to be honest. But these are the sort of higher end Mal pistons and everything. So what we'll do, we'll give everything a clean. I'll stop talking nonsense here, and once it's all cleaned and washed, then we can start measuring everything, and I'll also ring gap the piston rings to each cylinder, and from that stage on you've then, each piston is already matched thanks to the machine shop. So I'll take it out of the box, I'll get the block all cleaned, set it in order so I know 1, 2, 3, 4, the space of the pistons. I'll put each piston to its respective bore, and then we'll start gapping the rings. Once that's done, we'll do a dry assembly, and we'll check all the clearances, and once we're happy with the clearances and everything's good, we'll do the wet assembly, and again we'll come back to lubricating, not this section, but when we put a bearing shell in here, we'll put this lube on the bearing shell, and then we'll put the crank in. So not much else to talk about. There's a quick shot of the heads, and they're all, again, they'll need cleaned, but at this point we're not ready to go that far. I've also got a nice Roger Clark Motorsport baffled sump kit, and that's all supplied by OCS Performance, so thanks Johnny. I've got an inlet manifold, and I went with the TGV deletes there as well. Basically just get a bit more airflow on high boost. So it'll be new gaskets obviously in between the manifold and the TGV. This will all need a good clean. It's just off an old car I got on eBay as parts. I just wanted an extra one, so the plan is I want to assemble a complete, basically a crate engine, have it sitting on the bench, and then do a whole swap. So as the car needs new injectors, bigger injectors, eventually I'll go with the bigger turbo kit as well. But it's all, you know, build it up in stages. But for now, the plan is to build the engine, have it sitting here. We can put in wiring loom later and everything, and just swap the final bits over. And that should be it. So fingers crossed, let's go for it. Okay, so here's a better shot. We've got all the bearing saddles cleaned. We've also dried off the block as much internally as possible, and got all the pre-lube off the bores. So you can see it's a nice pattern there. It's all been machined to fit. Same on this side, the closed deck, it's all nice and shiny again. I will lubricate this again, and you do have to lubricate it as you go. See, there's some old lube, I'll clean that off. But as I'm leaving it overnight, I'll put some engine oil down the bores just to prevent rust. But yeah, aside from that, we're all good. Everything's getting a nice clean. So next stage is we'll match up the pistons and take our measurements. So you want to measure all, putting the block together, you can put it together, tighten it. You want to check your line bore for the crank bearings. You want to check your clearances in the bore. Just double check everything, because as good as the machine shop is, you need to know yourself, you need to know what you're working with, and you take further measurements as you go. So take your time, measure, and read the manual. Whatever you do, stick to the factory manual, or if you're using aftermarket parts, refer to the specific parts for that component, the manual, and just reread it until you're happy. But don't go using OEM specifications for aftermarket parts. Each component that you buy will have its own torque values, its own settings, and even how to tighten every nut and bolt. So yeah, you're reusing an OEM block, but each component has its own spec. So again, for these head studs, the engine builder gave me the sequence in which these need to be tightened and the various torque values at each stage. So whatever you do, aftermarket head studs have a different sequence and torque sequence, for tightening, than the factory standard. You will still tighten it in the same order so that you're not stressing and damaging the block, but you will go up in different stages in values. So this is the point, every engine build is unique, even when it comes down to doing the piston ring gap in here. The set of pistons from MAL, they actually specify for race use, nitrous use, turbo or supercharger use, or NA, naturally aspirated, and for each different setting or how much boost you want to run, there's a different ring gap clearance to go by. Reading the instructions this morning just before doing this build, and what the MAL pistons say is you take the diameter of the bore and you times it by a certain value, so like 0.007 inches. So for example, this bore is, I can't remember, as a rough guess, it's 3.95 or 25, something like that. So you take that value and you times that by 0.007. This is all in inches, and when you work it all out, I think it comes out as 0.0028 or something, and that's approximately 0.7 millimeter for metric. So really, I'm going to reread it, but roughly at the moment, I think my ring gaps are going to be about 0.6 to 0.7 millimeters, and that's for highly boosted applications and engines using these pistons. But again, if you go and use different set of pistons, it ain't going to be that ring gap. So do not match what I've used, because this block is overboard from standard, and it's also had a conversion, and I'm going to run an absolute bucket load of boost in this engine. So it might, might do one pass, it might go 100,000 miles, who knows? I don't care. It's just for fun. But don't copy my values. Always refer to your manual. So that's my disclaimer. We'll get that out of the way. Now we're going to have some fun, and we're going to line everything up, take some measurements, and get the piston ring gaps done. So what I've done is used this bore gauge. It's a bit of an old-fashioned one, and I've put it inside the bore, and I've tightened the end. So you wiggle it about in the bore, tighten the end, and then you get your vernier calipers and you check the size. That gives you your bore, and also you check your piston. So this whole engine is roughly 100 millimeter bore setup, so it's been overboard from the 99.5, so I think that's 2 steps up. You go 99.75 and 100. So this is like, obviously I got this engine on eBay. It was like taken out as a case half. It was claimed it was an original engine, 100,000 miles on it. So I sent it off and they've bored it out. So obviously it's up to the engine builder what they feel they're happy doing on the machine work. So this is number 1 piston. So this is going 1, 2, so it's in here. So this will be this eventual hiding spot for this piston. But yeah, unfortunately the engine builder's marked 1 and 3, but he's also marked 2 of 4 and 2 of 4 the same. So I'll have to measure these and see which one is actually number 2 and number 4 piston. But at least we're on a start. We've got 1 and 3 to start with, and we'll do the we'll just crack on. Okay, folks. So I've just been doing a bit of a calculation here from inches to metric, getting all the feeler gauges laid out, and this is your ring plan for how you actually have to have the ring gap set up around the piston, and each piston has an arrow sent to the front of the engine, which the back is going to be your flywheel side. Here's the front where your oil pump will go in the middle. So this piston will go like that in the bore. So what I'm doing now is I've used the piston to gently push the oil scraper ring into place to make sure it's even the whole way down the bore. And I'm going to measure this. Maybe you can't see it. It's a tiny gap. And what the minimum says for my engine is 1.5 millimeters. So I'm going to get my feeler gauges and try and put them in that gap. And if it's not big enough, I'm going to put it in the vise and I'm going to hand file it until I get at least 1.5 millimeters, because that's the minimum clearance you need to actually be safe and have good tolerances. So basically it's quite boring. You just check, measure, check, keep going, file a bit off, and you do that for every ring. So you have a top and bottom scraper ring on the oil ring, a metal ring, and then the spring part, and then each piston is going to have its first and second compression rings as well. So you've got top ring, second ring, oil scraper ring. For number one piston, we're working on the oil scraper ring now. So it's quite a boring, slow process, but that's why people charge a lot for building an engine, because it's physically taken a lot of time. So just enjoy it, go with it, and hopefully you learn a bit in the process. Okay, so after the little time lapse, I'm still going. The original gap with this in the piston bore was 0.4. I want to go out to 1.5. So it's really slowly as you can. So what I'm doing is I'm putting it in, and I'm just using, once you get it in the groove, I'm using a piston to push it down and keep it flat. It's a little hard to do this one-handed, but basically you get, I'm going by the same measurement every time, roughly there, keeping it flat against the deck head. And now what you can see is, ever so slowly, that gap on the oil scraper ring is increasing. So we want that gap to be at least 1.5 mil, so that once the engine's up to temperature, you have all the proper clearances, nothing seizes, nothing nasty happens, and you don't write off your new block. So basically I'm going to do that for the top ring, the bottom ring, and you don't need to touch the intermediate section. So these three rings comprise the oil scraper ring, and then I have to go and do the exact same process for the top compression ring and the bottom compression ring. So you'll have the three, as I say, in order, and they will fit on those grooves. So let's see, top compression, second compression, and your oil scraper, and then this is your piston skirt. So basically, yeah, that's the process, and those very nice pistons. Yeah, I'm just going to keep going with that, and there's nothing much else. Once I've done number one piston, I'm going to keep it to the side. Everything will be labeled, they'll not move, they'll stay in their order, and then it'll be ready for actual assembly. But basically the process is, I'll gap all the rings, the pistons are matched to the bore, we'll put those to the side, then we can go and get our shell bearings, our ACL bearings, and we can check the clearances on the saddle and the crankshaft, and we'll give it a good clean, and then we'll do a dry assembly. So it's all this prep work you have to do, and so far I've been at this maybe a couple of hours by the time I've worked out the measurements and needed, read the manual thoroughly. I can't stress that enough. Whatever you do, read the fucking manual, please. Just general brake cleaner, and that's about it. So it's a slow and steady process. Put some tunes on, chill out, enjoy it, and just have the satisfaction that you're building the engine for yourself. So hopefully you enjoy the video, and I'll keep on cracking on it and give you an update later. Okay, so I've gapped the two rings for the oil ring. I'm going to keep the oil ring together so that when the piston assembly, so that'll go in the middle. That's my way of remembering. Just have a system yourself so that you know what you're doing. Now I've taken this out of this packet, so we've got 1, 2 and the oil scrapers. So this is one of the top compression rings, and hopefully if we can get a better angle on it, you can see that mark on the right there. It says Manly. That's actually, there's normally a dot or a manufacturer's mark, and that's to say this way up. So actually this ring mounts on the piston, and the piston goes in this way, and this is the top side of it, so it's facing the head. So that's how you identify it. There's always a small mark just here. That's why it says read the manual, because this is really critical. Now I've just put this in and it's extremely tight, and it's 0.05 mil most clearance. I'm going to have to hand file this. And the thing with the filing is, I didn't describe it. What you want to do is you file inward. That's what the instructions say. And I'll only file one side. So pick a side, and obviously you can use a ring grinder or hand file, whatever your choice is. But pick a side and then stick to it. Don't go filing both of them. So I'm going to go on this side because it's offside of this. So it's just my way. I like this. So there's my top, and I'm going to file with the file going inwards, and I'll just keep doing that gently and checking the clearance and putting it back in, taking it out. So hopefully by today I'll have done one piston. Actually, looking at my time, it's probably taken a couple of hours. It's been a slow start, but I just want to take my time, get back into the feel for things. So there's no rush at all, just enjoy the process. So I've got my feeler gauges, got my top compression ring, and I'm going to aim for, I think it was minimum stated is 0.68 mil. I'm going to go for 0.7 mil. That'll be a nice round figure. Get it to that, and that should be for the high boost. Basically anything over 15 psi, it says go with that sort of value. Totally up to you. I mean, the tolerances are so fine when you're measuring with feeler gauges. It's kind of best fit. You get a feel for it. Putting them in, do they slide, do they not slide up and down? It's not an exact science, you're basically getting as close as you can, and feels good, and you sort of go with your gut instinct after that, because you do get a feel for what you're doing. So just take your time. It's better to check more frequently. That's why it takes me longer. I'll do like about 10 to 15 strokes with the file, put it in, sort of wipe it off with a bit of brake cleaner, put it in, measure it, come back another 10 to 15, and you sort of get used to how much material is coming off the ring with each sort of set amount of strokes, and that's how I gauge it. So just practice makes perfect. So that's 2 down, another 2 to go, and that'll be piston 1 complete, and 3 more remaining. Okay, just to give you an idea of how I gauge this, I've used the piston, tapped it in, so it's the same distance the whole way around. And this is a 0.3 feeler gauge, and as you can see, it fits in there. It's actually, yeah, I mean, it's kind of tight. So another couple of strokes of the file, and that'll be like, well, yeah, it's getting there. Almost a perfect fit for 0.3. Now I want it, yeah, you can pull it through, so that's good. Yeah, that's good. It's a bit hard one-handed to sort of demonstrate this to you, but anyway, what I'll do is I'll bring this out from 0.3, keep filing up to 0.4, check at 0.5, 0.6, 0.7, and then once we hit 0.7, that's that ring done, and we're all good, and we'll move on to the second one. But yeah, that's just to sort of show you how easy it should be to get in the gap there. Hopefully that light illuminates better, you can see the gap, and you obviously want a nice flush edge, and once you've finished filing off, you want to sort of gently make sure the corners, there's no sward for any kind of sticky bits there that are going to damage your bore. So again, it's just sort of going on sort of own knowledge and your own fitting techniques, but that feels pretty smooth. There's nothing that's actually sticking against my finger like a nick that's kind of stopping me move it, so that's nice. Pretty good there. So I'll just keep going and then show you the end result. Okay, there you go. There's the 0.7 mil, and it's free to move, and it's pretty much bang on. So, and again, measure the ring is in the bore at the same height from the deck, so it's just to kind of have a bit of continuity there. So that's the top compression ring done. We'll take that out. We'll keep it in the pile with the top ring there, and then one more to go. from the number 2 packet, and that'll be the piston complete. Okay, so we've got the bearing shells now. So these are the big end bearings that the crankshaft actually sits in, and you put them in each side. The interesting thing to note is this is your rear end, your thrust bearing, so it matches up on each case. You've then got the slightly thinner one, thicker one, thinner one, thicker one. So these are all out of the same pack, so you put them on matching, because actually these saddles are slightly thinner here and thicker here, thicker here, thinner here, and thicker. So just to be aware of that, these are where your O-rings and things will go. And here we've got the connecting rod bearings as well. So plan is now I'm going to wash the crankshaft down, make sure it's all clean, give everything a dust with brake cleaner and a blow with dry air to make sure there's no dust in there before I assemble it all together. And then just do a dry torque and bolt everything together to check the clearances. Okay guys, so since the last frame, it's been a couple of days. It's in between Christmas and New Year, and what I realized I've done is I've gapped the wrong clearance on the oil rings. Basically what happened, I was using Google on my iPhone to to convert from inches to millimeters. I made a really stupid mistake, and what happened was I was looking through the Subaru technical manual, just sort of checking clearances for the crank and the bearings, and then something clicked in my head and I thought, that doesn't look right. I went back and I suddenly realized that the compression rings are good and I've used the wrong clearance on the oil ring. So the machine shop doesn't open until first week in January, so there's nothing I can do about it right now. I just have to suck it up. It's a real pain in the ass, to be honest, but shit happens, mistakes happen, and I caught it in time. So other thing, what I can do is I can crack on ahead with measuring. What I'm going to do is measure all the crank journals for the main bearings in the block, and also where the connecting rod's attached. And also what I've done is, off camera, I've put the bearing shells into the actual block, and I put the 2 case halves together, and I've actually gone and torqued it up with the water jacket bolts. Now there's let's see if I can do this with a finger, there and there, and also there and in there, and then there's 4 on the other side. Let's see, yeah, there and there, and then another 2 go into the actual block in there. So yeah, it's torqued up 40 Newton meters, so that's actually the torque that the case is under now if your crank was inside. So what we're going to do is we're going to measure this size here with the bearing shell installed. We'll make a note of it for each main bearing point up to the thrust bearing at the end, and also we'll measure the crank. We'll do some maths and we'll figure out, that will give us our oil clearance. Now I'd already gone and measured these, but to be honest, my eyesight is kind of crappy at the moment, even with glasses on. So I do have an old-fashioned micrometer vernier caliper around here. I've been using the verniers for yeah, basically measuring everything, but it is a bit hard to see when you're going down to 1/10 of a millimeter. So I've got this one for the crank. I'm also going to double up. I've also got, what you do is you put this in here, that will get you clearance, and then you measure this with a vernier caliper. So there's various different measuring instruments. I have gone, because I'm waiting on a good quality micrometer coming, vernier caliper, I've got this cheap one because it's basically as a backup for the analog one, because I can't really make it out too clearly. So we've got this cheap crappy digital one. It's okay, but reliability, repeatability, I take the same measurement a lot of times just to make sure that it's actually reliable. What I'm going to do is get a good quality one, and then I'm going to recheck all the clearances again. This is actually crap. It's Magnuson. I got it for like £20 in Screwfix, and to be honest, it's not really impressive, but it's a good backup to the analog gauge just to have a second opinion in the meantime. Once I get all the clearances measured, then what I'll do is go and order a size of oversized bearing shells under oversize. So these are for the connecting rods. These should be okay, but you never know, have to check them. But the main issue is the bearings, and what I found was on the first rough kind of measurement, number one, say the oil pump, the front of the engine, big clearance here. Excuse me. Then the next couple were okay, but the clearance actually, it's close to tolerance on number 2, and the rest get wider. So if you imagine like a V formation, it starts kind of big clearance here, and it just gets wider as you go towards the thrust end. So again, that's probably because it's a used block, it's been machined all here, but what happens is your actual shaft line with the crank, the tolerances go out. You know, it's apparently this engine had 100,000 on it, so even putting new bearings in, you're going to have to go oversize or something. As an example, the max tolerance is 0.4 mil. I was getting like, I don't know, 0.9 on one of them, so you need a 0.5 oversized shell bearing to put that in to drop it down to the max oil clearance. Other way is I've got high flow, larger volume oil pump, and you can also change the oil viscosity. So if you've got a bigger clearance, you can put, you know, thicker oil, higher flow pump, and that'll sort of make up for the difference. But again, every engine builder prefers their own thing. I'm not saying that's the right way, the wrong way. It's just what I'm going to do. So my personal preference, I'm going to do it. It's my engine. I'm going to, you know, the engine's going to take high boost. Why not have a bigger clearance for a bit more oiling, because the pump can, you know, obviously supply it. So it's up to you. If you're running a street engine, OEM, stick, you know, try and go with what your builder says. You know, probably go factory Subaru clearances, whatever. When you start getting into really high horsepower builds, it's kind of up to you, up to your builder, what you want, and then you have to kind of, you know, just go with what they suggest. But every engine's going to be different, and you know, you sort of check your piston ring gaps as well. You're going to have a larger gap on a higher boost engine, so like your compression rings will have a higher gap. This is important. All the tolerances change with temperature, so you don't want your engine seizing up. So basically, a lot of companies, they'll have like a build recipe, and they'll say, like, you know, this engine's rated for 500, and they just build it with their tolerances to that spec every single time for repeatability. For my last engine, I sort of noted down everything. I was happy with it, still going 6,000 miles later, anti-lag, hellfire, everything, it's good. So for this engine, I'm just going to recheck the clearances, get some different bearing shells, and I can mix and match, and we'll take it from there. Okay, so here's just the highlight. I've done the front, the second, and this is the third. So here's your caliper, and what you're doing is you're just gently putting it down there, if you can see this, so that the surfaces are touching. You want to get a good clearance, and you can see basically, does it fit around the journal or not. Now I've kind of sized this so you can see what it feels like, hopefully on camera, and there you go. It's coming up to about 59.9 or 89. It's moved a little bit, but I also checked it with this caliper, and I got 59.4. and then what I'm doing is I'm going to record that on the spreadsheet, and that'll be your sort of your size of your journal that goes into this bearing. Then we'll measure the equivalent one on that side and subtract the two to get the difference. So basically, working my way through the crank, once double checking it, just to make sure, you know, so you want to have like repeatability. I'm getting at the moment within like a 1/10 of a mil, so getting there. Practice makes perfect. And this is the old analog one, so basically there you go. If you can see this, what happens is when you get a number here, so as that slides, that's say 60 approximately, right? And then what happens is once you're on the 60, you look at these smaller numbers, and they'll give you like 60.1, and in between that again is 0.02 of a mil. So even with your glasses on, these are so, they're so difficult to read precisely. You have to know firstly how to read them, and then secondly, is your eyesight good enough? If not, take a photo, and what you find is it may look okay on here, but when you take a photo of this and zoom in on your laptop, for example, there's a huge difference in these graduated lines here. So it's more difficult than you think. That's why I went to a digital one. Again, this is a cheap and nasty digital one. Seems to be doing okay for now, but I want to go and buy a good quality one when the shop's open again, and I'll recheck these. So basically, I'll have checked the crank twice, And it'll just be interesting to see what the difference is between the manual analog and the digital, and a really good quality digital. But at least you know then your clearances, you know that your tolerances are good because you've checked them, you've double checked them. Basically measure as many times as you feel comfortable until you're confident that the number's accurate. So this is a huge part of the build. Take your time on it, do not rush it. The other thing is temperature. Always take the measurements at the same temperature. Now in Northern Ireland here, it's freezing, it's winter. I'm never going to get the perfect 20 degrees temperature unless you bring them into the house, and my wife ain't going to have that with the block sitting in the kitchen. So you know, at least now when I'm taking them, they're all the same temperature. And one other thing, this little cap full of oil, put that on the threads of the water jacket studs when you're putting them in so that you get the correct torque. It's really, really important. Don't put them in dry. You will not get the right torque, and that will then affect your clearance readings. So loads of small things to be aware of. But just, again, read around the subject. Don't listen to everything you hear on the internet, including myself. Take it with a pinch of salt. And just do your homework and recheck measurements, and don't end up like me screwing up an oil control room. So yeah, but that's what a lot of YouTubers don't show you online, is people are perfect, they don't make mistakes, which is utter nonsense. So hopefully my build is a bit more realistic. There's no cheerleaders, there's no you know, it's not like souped up for Instagram or anything. It's just me standing in my garage taking measurements, which is boring, but that's what makes horsepower. So hope you enjoy it. Okay, so since the last scene, it's been a few days now. Basically I'm going back to work. I don't have much time now to sort of produce any more content, but what I've done is thank you so much to Roland Allsop. They're an engine machine shop that specialise in Subaru. They managed to get me another set of bearings which will actually decrease the clearance on the crankshaft and the case halves. And also, because I made the mistake with the piston rings, they got me a matching set of manual piston rings for these pistons. And what I'll do is I'll just throw away, next time I start the engine, I'll throw away these oil rings and re-gap them. And then I've also got a spare set of piston rings as well if I need. If I decide to change my mind, I can set different tolerances. So basically everything's on hold now. What I've done is I've coated everything under this box, if I can show you. All the bearing shells. So those are the original crankshaft main bearings, and these are the connecting rod bearings. There's actually some spare there. I've coated them in some Castrol engine oil just to protect them. They don't actually need it, but I just like to do it. And also the block halves. So the bore, I coated with some assembly lube, and also the top of the deck as well. Aluminium block and all, but it's just good protection. So I've done that on both of them. They're both coated. All the sort of machine surfaces have been lubricated just to keep a nice oil film. As with the crankshaft, I poured some oil down each bearing, the oil hole, and covered each journal with oil. So that's well lubricated, covered, protected. Piston skirts on the side of each piston I've lubricated. Also, I didn't need to, but piston rings also, just because I've been filing the end gaps. So basically everything that I've touched, I've lubricated again for storage for long term. I just think it's good practice. Some people say you don't need to, personal opinion, but I want to, and it takes 5 minutes. So, and also the heads are down there, they're going to wait. I need some parts for those. So yeah, so the bottom end will continue. We've got the bearings, everything's good, and that's about it for now. So I'll produce another video in a couple of months' time once I could kind of get work over with and get back into actually getting a bit of time off and doing some building. So I hope you enjoyed it up till now, and please like, subscribe, and share the channel if you do like it. So thanks very much.